Have you ever wondered why technology and devices like this phone I'm holding exist? Or have you ever asked yourself, how were the branches of mathematics that we study today created or discovered? We learn math in our classroom. Algebra, geometry, statistics, trigonometry, and even calculus. But we rarely ask, where did all this come from? Or what idea started everything? With that, we will talk about the foundations of mathematics, the root, the origin, and the deep structure that made all the branches of mathematics possible.
But before we explore each foundation in detail, it's important to understand why they matter. These foundations act as the backbone of every mathematical idea we use today. Without them, the structures of algebra, geometry, trigonometry, and calculus would not exist or make sense. They give order, clarity, and meaning to all mathematical thinking.
The foundation of mathematics are the basic ideas, rules, and principles that mathematics is built on. Just like tree grows from its roots, mathematics grows from its foundation. This foundation explains two main things. First, where math came from, source of number, shape, symbols, and concept. Second, how math works at its deepest level, the rules that keep everything consistent and logical.
Without these foundations, mathematics would fall apart. It would be full of contradictions.
Every branch of mathematics exists because of the foundations: algebra, geometry, trigonometry, calculus, and statistics. All of these grow from the same deep principles. So yes, the foundations of mathematics are the reasons why we have many branches of math today. It is because these foundations gave shape and structure to all mathematical ideas.
The first foundation is logic, the science of correct reasoning. An example of this is if it rains, the ground gets wet. That is a logical statement. In mathematics though, logic helps us determine if an argument is valid or not valid. It keeps math consistent and prevents us from making mistakes. Because of logic, we can create proofs, algorithms, programming languages, and even logical computers. In fact, your phone is made because of Boolean logic, a foundational mathematical idea.
Now that we've seen how logic strengthens the way we reason, we can look further into how mathematical ideas take form. Once our thinking becomes precise and consistent, it becomes easier to understand how different concepts connect, how patterns emerge, and how mathematics organizes the world in a meaningful way.
Second, we have set theory, a combination of objects. For example, set A is equal to 1, 2, and 3. Set theory might look simple, but it's actually very powerful. All modern mathematics can build from sets, such as numbers, function, shapes, and even equation. Set theory gives us a universal language for all math.
And after seeing how mathematical ideas can be grouped, related, and structured, we begin to notice that these relationships are guided by deeper principles. Mathematics does not grow randomly. There are fundamental truths that steer its direction, providing a strong base on which the rest of the subject is built.
Third, we have actions, the basic assumption that we accept as true without proof. They are like the starting point of a game. Examples from geometry. Through any 2 points, there is exactly one straight line. From this simple rule, we build the entire subject of geometry. When mathematicians change an action, it creates a whole new branch of mathematics, like non-Euclidean geometry, which helped Einstein describe space and time.
But even with these underlying truths shaping mathematics, we still need a way to ensure that every idea built upon them is reliable. In mathematics, nothing is accepted simply because it sounds right. Every claim must be supported, every conclusion must be earned, and every statement must be shown to hold under all conditions.
And fourth, we have proofs, a logical explanation showing that something is always true. For example, to prove that the sum of two even numbers is always even. We use logical steps, not guessing. Proofs gave math its certainty. If something is proven, it is true forever. Not sometimes, not maybe, but always.
And once we understand how proofs secure the truth of every mathematical idea, it becomes clear how powerful these foundations truly are. They don't just shape the way we reason on paper, they influence the systems, structures, and ways of thinking that extend far beyond the classroom.
Even though the foundations of mathematics didn't focus on technology itself, they gave birth to the ideas that powers today's digital world.
Logic gave us programming, set theory gave us data structures, and proof gave us secure systems.
So when you use a phone, computer, or calculator, you're using modern tools built on ancient foundational ideas of mathematics.
The foundation of mathematics are the these principles that explain where math came from and how it works. Because of this foundation, we have many branches of math today, from algebra, trigonometry, geometry, calculus, and more. This foundation keeps maths consistent, logical, and reliable. So, the next time you solve math problem or you use your phone, you should remember
Everything started from the foundations. They are the roots that support every mathematical ideas and even the technology we use every day.
And as mathematics continues to expand, these foundations will remain our constant guide. They remind us that behind every formula, every theory, and every breakthrough, there is a solid beginning that made it possible. From the simplest calculation we learn in school to the complex systems that run our modern world, everything traces back to these core ideas. They show us how far human understanding can rise when it is built step by step, truth by truth, on a strong and unshakable base. And with all these wonders that mathematics has given us, one thing becomes clear. You should love math because it is the language that shapes the world.